Hey everybody, and welcome to another JASP tutorial. We are continuing our Learn Stats series with this video. We are going to jump into confidence intervals. Ooh, we have 3 more to do, including this one, confidence intervals. Before we click that button though, we are using 0.18.1. This is my Intel Mac. So jump in there if you haven't gotten that. This particular version is where all of the Learn Stats modules are in full beta presentation as opposed to not full beta. Like, ooh, are they buggy? We'll see. And so as we continue this series, remember, Learn Stats, how you get that is they come with JASP. When you download JASP, it may not be on your top bar here. All you have to do is click on the plus button here and find it and click it, right? So it's in alphabetical order. So Learn Base and Learn Stats are right there. You just check that box. It appears on your top. So it comes with it. You don't have to worry about installing it or anything like that. It's ready to go right off the bat. So you can use JASP in your teaching and in your learning. So let's go into Learn Stats and talk about confidence intervals. Not a ton of options in this particular module of Learn Stats, but that's okay because confidence intervals are not meant to be super complicated. They're not meant to be super complicated. They can be if you're, running on empty or something like that, or you're not fully versed with it, but that's okay. So a couple of things here to note when we get started. So by default, you get the tree plot. And if you have been looking at a ton of, let's say, reproducibility papers by the Open Science Framework, a lot of different meta-analyses, that kind of thing, they will show you this tree plot. And so that is why it is marked here by default, okay? So what you get are the results table from your simulation, which are these values here. You get the tree plot. You get some show information here, but it's this comes together with the tree plot, okay? And then we have a couple more plots that I'll talk about as we go through this. So before we get overwhelming, let's talk about what comes up by default. So we have to set our parameters for simulation. This is a simulation function of JASP. You don't have any other input other than what these values are right here. So just be aware of that. Okay. So we got to put our mean in, and this mu here is a standard normal 0, and our sigma is 1. So this is a standard normal curve if we were to plot this distribution. But of course, that's not exactly what we're doing here. What we are doing is is sampling, is simulation of sampling. And we're going to do that simulation 100 times. So we're going to sample 10 values from these distribution, from this distribution, I should say, 0, 1, okay? And we are going to get our most common confidence interval level, 95%, and I'll show you how you look at that on this tree plot here. And like I said, we're going to do that 10 items or 10 values 100 times. So we're going to end up with 1,000 individual numbers all rolled into one, if that makes sense. Okay, so that is what we're going to do here, and that's what happens over here. So we did 100 repetitions on this results table, okay? Our mean is 0. Our sigma, or standard deviation, is 1, okay? We did it 10 times for each repetition, and we end up with a 96% coverage. Coverage value is how well we have covered the items in our, how well we covered our mean in each of our repetitions. How well we covered our mean in each of our repetitions. So 4 out of 100, we did not capture the mean in our confidence interval. Okay, so let's take a look at what this looks like on the plot, the tree plot. This is a big plot, okay, because we start at 1 and we go down to 100. So rather than starting, although I honestly would prefer it to be flipped, I'm not entirely sure I don't use tree diagrams. I've never really used them. So I don't know what the convention is. Maybe you do start 1 at the top, trees, I guess, and you work your way down. Now, this is a movable x-axis. Our observed mean is 0, right? So that is, or our true mean is 0. That's what this vertical dashed line is. Our observed means are going to be these diamond shapes, okay? And then our 95% confidence interval are the wings of these diamond shapes, right? So that's our 95% confidence interval. Now, we can also display the table where these tree plots came from. And the table should pop out right here. Oh, nope, popped out down below, okay? And so it's only going to display the amount of, I guess, branches, if this is a tree plot, that we specify, okay? And we can increase over here, +1, so we can add another one. So show me number 4 right here, okay? And we can do that, or we can do an additional 10, which will bring that to 14. And we can do an additional 10, and we can go all the way up to show last, which would be 100. So I'm going to show you what that looks like if we go all the way to 100. It's going to take a little bit to put all of those in, okay? The awesome thing about the tree plot in JASP is the ones that miss are identified in red. Why do they miss? Because look at their the arms of the observed mean, the 95% confidence interval. We're looking for that mean to be within that confidence interval, and of course, this one doesn't make it. This one is just a wide confidence interval, and it makes it. Now, these two, oh so close, including this one. okay? And then the table will show all 100, depending on how you have decided to show your repetitions, right? So what it will do is it will give you a value of that mean, right? Because it did it. It found 10 values. Those 10 values, how do they converge on that? Well, there you go. And then what their standard deviation is, right? So the standard deviation should be somewhere around 1. And then our 95% confidence interval for the mean and the standard deviation as they are. These are our upper and lower limits, which you can get in most functions over here. You can get your 95% confidence interval for a bunch of stuff. And then confidence interval contains mu, right? Those are our misses, and we get yeses and no's. And those yeses and no's, black for yeses, no's are red, okay? So that is what confidence intervals look like on this tree graph, okay? This tree graph again. You can fix your x-axis to show specific numbers, and so you can scrunch them, you can widen them, whatever it looks like. I think this might actually be a little bit better to use the fixed width of 2 to -2 if we're using the standard normal curve right there. We can change these values to anything we want, by the way, and we can change how many sample sizes, what our sample sizes are. We can change our confidence interval. If I change this to 99, these things are going to get wider, and we have better coverage. And that's because a 99% confidence interval technically is a wider interval for capturing that population mean, which is mu. And you can see some of these values don't actually have their wings on them. I wonder if that's just a display glitch because this one's black and that one's red. So I'm not entirely sure. I don't know which numbers those are. So, but of course, we only missed twice, right? So our coverage is 98%. So we only missed twice. So this one's a no, right? So negative value here, 2 negative values. So we missed that. And then the other one, number 3, we missed. Oh yeah, 2 positive values. I wonder which one. Okay, so 1, 2. Oh, there's another one right there. 3, 4. There's another one right there too. Oh, apparently they're good though. Where's the first? Where's that no? Where are you? No. There it is. 1, 2, 3. Okay. I think that's just a display. That must be a display glitch. Yeah. Okay. All right. Good thing to note about that for 99% confidence intervals. Good thing to note. But let's change it to a 90% confidence interval. I am less sure. So my bands are going to be less, are going to be smaller, right? So my little wings are going to be smaller, as you can see. And our coverage is only 90%. So you might be, or 91, excuse me. So you might be wondering, we got 96 for our 95% confidence interval. We got 98 for our 99% confidence interval. And we got 91 for our 90% confidence interval. Interesting. That's how confidence intervals work, right? So our convergence should converge on our confidence interval percentage if we have a sufficient number of repetitions, right? So 100 repetitions is a pretty decent amount of repetitions. We should converge on or be close to that, right? So if I go back to 95, again, I should be having a value that, look at that, 95. Couldn't have asked for a better outcome recording this video, right? So again, these values have changed, right? Computer completely resampled all repetitions of 10 values, right? And so all of these numbers are different. The ones that miss are different, right? So number 3, I think, was a miss on that one. So now it's number 6 missed on that. Repetition number 6 missed, right? And so we have one more miss than we had last time when we did a 95% confidence interval. But there you go. That's how that works. Now, if your computer is not as strong as mine, although I will say this is a fairly old computer now in computing terms, it's like coming up on 4 years old now. So you might want to just keep it as low as you can. Otherwise, you might be stuck with the circulating computation graphic. So that is confidence intervals, and I do love the tree graph and showing which ones hit and which ones miss. No graphic glitch on this one either on having the confidence interval arms popping out. I wonder if it's just a 99% confidence interval glitch there. All right, last 2 things that are going to show up after this table. The data distribution plots. These are very similar to the data distribution plots that you'll find in some of the other ones that we done on the channel. So normal distribution, binomial distribution, definitely central limit theorem, and standard error. Those 2 have these kinds of plots. And what they are box plots. So they show the sample. Okay, so what were the values for each of the 10 times, and then their distribution along the box plot here, right? So it shows our IQR in the blocks, and then the whiskers here are our 25th percentile and our upper 25th percentile, well, 25%, upper and lower 25%, right? And so these are each of the repetitions. So each repetition has 10 dots, creates a box plot, and then has a distribution curve for that for density, right? And so all of these density curves look a little different depending on what they are, and you then will see until sample number 100 again. This is made by Europeans, and so this must be how they abbreviate number. Now, again, you can do what I've mentioned before. You can do first number of repetitions, last number of repetitions, arrange between those repetitions, or all of them. I wouldn't recommend this if your computer is not super strong. So just remember that, okay? So we'll be fine. I'm sure the rest of the 100 look very similar to these. And then the final one is the convergence plot. This will show up at the bottom here. This shows us our 95% confidence interval line, right? That's in red, 95%. And then this line here represents the converging of our sample to that, but with uncertainty around it. That's what the blue is. So we have number of repetitions, not as certain. And then as we converge on 95%, our uncertainty gets smaller and smaller and smaller. That's exactly this is, if you go from here to out here, if you go from right to left instead of left to right, there's your cone of uncertainty for hurricanes. That's exactly how cones of uncertainty work for confidence intervals. That's all they are, confidence intervals. So of course, as we go further out in time, we are less certain about where the path of the hurricane is going, but we know that it'll probably be within that cone. And of course, it's smaller closer to where we currently are in time. And so that's over here, and then it broadens out, and that's why this confidence interval. And then you can zoom in with a margin here. You can zoom in, right? Or we can make this bigger, 0.5, right? Oops, sorry, we can't go higher than 0.02. Oh, there you go. We can go with a little bit higher of a margin around our line, right? So it brings us in a little bit closer or a little bit more far away. We can go in with 0.1, oops, and it'll get a little bit bigger for us to see, right? We start at 0.05 and then we go up there and the 0.95 is right there. You can see how that works. You don't have to zoom in here. You can just kind of see how you did. Now, the best part of this confidence interval module is not using standard normal curve of 0, 1. You put your own values in here and see what happens. That's the kind of thing that you would use this in a teaching situation or a learning situation if you had confidence intervals to work with. So that's how you use the confidence intervals function of the Learn Stats module. If you have any comments, suggestions, questions, or other feedback, please leave those in the comments down below. Thank you so much for watching this episode. I'll see you in the next one. Bye.